Hello, so my presentation is on the Upper Guyandotte Watershed in West Virginia, talking a little bit about the Guyandotte River in general, and then the health of the watershed and TMDL discussion. This picture here is a picture of the Guyandotte River coming from Logan, West Virginia. The Guyandotte River is a tributary to the Ohio River. It's approximately 267 kilometers in length. It has 13 cities running along the river, with an estimated population of 329,000, and it drains roughly 1,680 square miles of land surrounding the river. In the bottom left-hand corner, we see a picture of the Upper Guyandotte Watershed in general. It just gives an overall location of where the Upper Guyandotte Watershed is, and it shows the surrounding watersheds in southern West Virginia. This slide here shows a map of the the Guyandotte River in general. I'm specifically looking at the Upper Guyandotte in the lower middle of the screen. We see at the top where we have the marker where the Guyandotte River runs into the Ohio River at Huntington, West Virginia. On the right hand side, we have the percent land cover according to use, with it mostly being the Upper Guyandotte on the bottom, mostly being covered in forest with 94.18%. We have 2.42% in agriculture, and then the remaining percent being with commercial, mining, and other. We also see on the bottom right-hand corner the tributaries listed by length. This is not a complete list of the tributaries, but we do see that the Mud River is a larger tributary of the Guyandotte River, and then going into the Ohio River. This slide here has some non-mining sources in the Guyandotte River watershed. On the left-hand side, we see 3 NPDES permits listed here. We have the town of West Hamlin, the Mill Creek Wastewater Treatment Plant, and the North Springs Branch Landfill. So we do have 2 individual industrial facility types, and then we also have an industrial solid waste landfill. And then on the right-hand side, we have the water quality observations for selenium in the Guyandotte River watershed. The 4 streams are just smaller tributaries going into the Guyandotte River, which have all been tested for selenium. And then we have the selenium totals for the average, minimum, and maximum, all of which are listed above the water quality criteria violations. So the Guyandotte River, particularly the upper section of the Guyandotte River, is listed on the 303D list. We have it listed for the aluminum, the CNA biological, fecal coliform, and for iron. These were listed in 2004, but it is also on the 303D list for the 2016. This is the data used to create that TMDL. The inventory of data and information used to develop the Guyandotte River watershed's TMDL. We have the description being land use, abandoned mine coverage, etc. The data category would be watershed physiographic data as well as environmental monitoring data. So the data used was the watershed physiographic data as well as the environmental monitoring data to develop this TMDL, and then we have some major factors including land use, abandoned mine coverage, which is listed in that table. So the methods used to develop the TMDL, we have an overall listing for the watersheds with AMLs, but no permitted point sources. AMLs were reduced first until in-stream water quality criteria were met, which makes sense. And then for the watersheds with AMLs and point sources were set at the precipitation-induced load defined by the permit limits, and AMLs were subsequently reduced. AMLs and revoked mining permits were reduced. Point sources were not reduced until in-stream water quality criteria were met if possible. And then for watersheds where dissolved aluminum TMDLs were developed, much like in the Upper Guyandotte and the Guyandotte River watershed, source allocations for total iron and manganese were developed first, since their total in-stream concentrations, primarily iron, significantly reduced pH and consequently increased dissolved aluminum concentrations. So overall, the methods used to develop the TMDL was a top-down methodology. And then we have the headwaters that were analyzed first due to its flow into the lower streams. So the tributaries would have been developed, and then going into the Upper Guyandotte River, and then the Guyandotte River running into the Ohio River. So the recommendations listed from the TMDL, this table is just a general applicable West Virginia water quality criteria recommendations. We have listed here the aluminum, the selenium, and the fecal coliform that are in violation for the Guyandotte River and the Guyandotte River watershed. So the overall health of the watershed, it's listed as severely impaired for iron, aluminum, fecal coliform, and biological. The criteria were all listed well above the recommended levels. We have levels of fecal coliform posing a health hazard to humans, and the levels that are listed also cannot allow for proper life in the stream, hence the biological listing. Here is just a picture at the bottom middle. You can see where it has impaired severely, and impaired moderately. Those are for aluminum, selenium, and biological. Just shows those three in order of the three that it was impaired for. Here's some NPDES permits in the Upper Guyandotte Watershed. We have the CSX Transportation. It's just for a stormwater industrial permit, and then we see that it's been renewed. We also have two listed here that are mining underground injection control. So the Big Bear preparation facility for mining sand or other backfill wells, it was renewed, and then it has a mining underground injection control, as well as the Paragon Henchman injection site. It has mining sand or other backfill wells, and then also mining underground injection control. And here's my works cited.